Hello and welcome to Echelon 1. Today we'll be creating another system within the platform, this one designed to schedule power on your ec2 instances. We'll do all this with some on-screen buttons and a bit of prompt engineering for the AI. Now you might be thinking, doesn't AWS have a built-in solution for power scheduling? Yes, they actually do. It looks like this, and this is only for a single account. Here's what an Echelon 1 power scheduler looks like, and this will support up to an infinite number of accounts. This is a great example of the power of Echelon 1. With that out of the way though, let's jump into the creation of this system. New system, ec2 scheduler. Make sure it's data backed, and then let's get started with our first command. This first command will be what we call a collector. A collector is simply a command that will gather or collect information about something. In this case, our ec2 instances. So, pick a target, which in this case here is our usual suspect first target, which is simply one of our targets with a handful of resources. Now for the first of our prompt engineering. Create a list of ec2 instances. Important properties are instance ID, name tag, if it exists, and current state, either stopped or running. Add a schedule group property to each ec2 with a value of an empty string. Finally, in each ec2 dictionary, add tenant alias, tenant ID, and tenant geo from the e1.tenant. This will collect the information we want, as well as adding a blank tag to each of our instances, which will make it easier to add them to different groups in just a moment. For now, this all looks good, so we can run it to collect information and populate our table. Back on our system page, we can pull the JSON from one of these entries and paste it under properties to give us a fully fledged table. Very nice. Of course, the schedule group property is empty across the board, just like we want. So let's set up another command to be able to add some of these entries to certain groups. New command, add or move to group. This will be a selection command. We'll add a required input to this command, a drop-down menu to select from our available groups. Our groups will be named dev and QA. Then just a quick prompt to engineer. For each selected resource, update the schedule group property with the value of group input from context. Pretty self-explanatory, but this will take our selected resource and add it to a group of whatever we selected from the drop-down input, either dev or QA. So now we can collect our instances and add them to a group, but what if we want to remove them from a group? Well, that's another command, so let's throw that together. New command, remove from group. This is another selection command. For each selected resource, update the schedule group property with the value of an empty string. Okay, great. We've got groups and we can move resources into and out of them. Our next command will be to start or stop instances. So, new selection command, start or stop instances. We need a couple of inputs for this command. Firstly, we need a group input with a short string. Secondly, we need a power input with a drop-down list of either on or off. Our prompt is a bit of a long one, but it should cover all of our bases. For each selected resource, we are going to either turn off the ec2 instance or power it on based on the power context input. The instance underscore ID should equal instance ID. Use e1 assume for each resource. The account ID is on the ID property and the region is on the geo property. Lastly, modify the resource state to either running or stopped and return the entire context.dataset. One last prompt for this command. Instead of the is_selected logic, act on resources that have a schedule group property equal to the group context input. I'm also going to copy the command ID here as well, since I'll use that here shortly. All the pieces are in place to group instances together and power them on and off based on said groups. Now we just need to create a schedule. New command, create schedule. Clicking on the paperclip, we can create a new sheet. We'll call it schedule. Let's get 4 columns and 3 rows together. We'll have a group column, start UTC, stop UTC, and days. Then we just fill this in with our groups and times we want scheduled. Our QA group should start at 1200 hours and stop at 2300 hours, Monday through Friday. Our dev group, 6:30 a.m. to 6:30 p.m. Saturday and Sunday. While we're in here, let's add another schedule. Application 1, 7 a.m. to 10:30 p.m. Monday through Sunday, all week long. Now we just need to get our schedule into our command. Download the schedules.csv using e1.file and save it to /temp. then parse the CSV into an array of dictionaries. Pretty straightforward. This will take our schedule sheet we just made and turn it into a dictionary in our command. Let's engineer our final prompts to get all of this into action. For each schedule, create 2 schedules using E1 package. The first schedule should follow the format schedule group on, where group is the property in schedule. The cron must use the hour and minutes specified in the start UTC property, which is in the format hours minutes. The second schedule should follow the format schedule group off, where group is the property in schedule. The cron must use the hour and minutes specified in the stop UTC property, which is in the format hours minutes. Finally, when creating the schedules, also account for the selected days on the cron. You must use question mark for day of the month. The days value is the days property on each schedule. If the days property is empty, use asterisk. On schedule, make the input dictionary have these values. Group, which is equal to the group variable, and power, which is equal to on. Finally, change your command ID to, then I'll paste the command ID I copied a few moments ago. Okay, I think that's just about it. Now we can run this to get everything created and ready to go. Now we can head back into our system and assign some groups. Remember when I added the application 1 group? Well, the schedule is made for it, but it's not actually a group we can select. No big deal, all we need to do is head back into our add to group command and edit the input to have an option for application 1. Now that we're back in the system, we can add this instance to our application 1 group just like that. Well, that's all well and good, but does it work? Well, good question, let's find out. I'll adjust the schedules to stop in, say, 5 minutes from now. It's Monday at 3:55 p.m. UTC, so in 5 minutes, both the QA and application groups should shut down. We've got the AWS console here showing our instances. QA Server 1 and QA Server 2 are in our QA and application groups respectively, and those are the groups set to shut down in 5 minutes. I'm not going to make us all wait that long. With the power of video editing, 5 minutes have now passed, and any second now, these instances should start to shut down. Refresh to see the first instance stopping, then a few seconds later, refresh again to see the second instance stop. It works, so now you could come back to update your schedule and you're in business. It's done, it works, and it works well, but it's not the prettiest thing. It's missing the cherry on top. I'm, of course, talking about widgets. Let's get some widgets going. How about a pie chart showing the number of instances per group? We can pull a sample dataset here to get our properties in order. Count instance ID, group by schedule group. How about a metric scale showing how many instances aren't in a group? We'll filter by schedule groups with an empty string, then simply count the instance IDs. It may seem underwhelming to see a 0, but that's $0 being wasted. Think about that. That's probably enough widgets, so how about some color to our table? If our schedule group is an empty string, we know it's not in a group, and if it's not in a group, it's not being power scheduled, and if it's not being power scheduled, it's potentially wasting money. Wasting money is bad, red color. If the current state of an instance is stopped, it's saving us money. Money is green, so stopped instances are now green. If the current state of an instance is running, it's costing us money, but that's not always a bad thing. Maybe we want it running. A cautious color, orange, shall do. Now, if we remove an instance from a group, we can see all the colors we've made along with all of our widgets working as intended. Glorious. In this video, we walked through the full creation and testing of a system, and we even made it look nice. We didn't use any coding, just a little prompt engineering using AI. If you liked what you saw and you want to learn more, be sure to check us out at echelon1.app. Happy automating!